We're all clear on it. So here's the thing. Normally in Sec 3 we'd say solve by factoring, and then if it can't factor, quadratic formula. So now we have two options. If it can't factor, completing the square or quadratic formula. So everyone, just a reminder, ax squared plus bx plus c. So my a value would be 12, my b value would be 5, and my c value is -3. It's all just being able to plug something in correctly and plug and chug and simplify. So we'd have x is equal to -b, so that'd be -5 plus or minus the square root. Everyone, you need to use parentheses exactly as you see it, so that would be 5 squared minus 4 times a times c, and then all over 2, all, not just a part of it, all over 2 times a. So 2 times 12 would have been 24. So now the hardest part for people is being able to type this part into their calculator. Now when we had graphing calculators, I said to you, just type that in exactly as you see it. Some of you have advanced enough calculators that if you type that in exactly how you see it, not with the square root, you cannot type in the square root part, you can get it right. But some of us, our calculators are not advanced enough. So make sure you can calculate that correctly. Everybody grab a calculator, make sure. So what you would do is you'd go like this. Look, underneath here would be this, wouldn't it? The square root of 5 squared is 25, isn't it? Then we have two negatives, that would make it plus. A negative and a negative. And then you'll do 4 times 12 times 3. So plus 124? Oh, 140, what? What is it?
144.
Oh, 144.
Sorry.
You're okay. So now rewrite it. You have x is equal to -5 plus or minus the square root of 169, right? All over 24. Now everyone listen, the next step is to go off to the side and say, by hand I'm going to simplify the square root of 169. And this will it comes out a whole number, which is 13. So we have x is equal to -5 plus or minus 13 over 24. Non-advanced thinkers would say, oh, that's my answer. No, it's not. They're all whole numbers. We can actually add them up. We can actually subtract them. There's not any radicals here. So we have two answers. We have -5 plus 13 over 24, and we also have -5 minus 13 over 24. So what are our two answers here? So 13 minus 5 is 8 over 24, which is 1/3. So there's our first answer. So that'd be -18 divided by 24, -18 divided by 24. They both divide by 6. Is that enough? So that would be -3/4. There's our second answer. This one actually would have solved by factoring. If you get fractions or whole numbers, it would have solved by factoring, but we're practicing the quadratic formula for fun.
On the test, does it like make a difference, right?
Yeah, it does. Okay, another one. Let's see how some of these answers come out. So you'd say x equals -b, so that'd be 3 plus or minus the square root of b squared minus 4 times a times c, all over 2 times a, so that'd be 4. Then everyone make sure real quick, type in and tell me what this is under the square root, please, so we can go quicker, so I don't have to pause and do it. So a few people do it, because if we only have one person doing it, they could be wrong. Yep. Square root of 81. This is another one that we go off to the side and we say square root of 81 is 9, isn't it?
Yeah.
So we have 3 plus or minus 9 over 4. So now go 3 plus 9 is 12. 12 divided by 4 is 3. There's one of our answers. 3 minus 9 is, so we have -6 over 4, which is -3/2. Okay, let's go again. So first of all, we have to subtract 4, because with all quadratics, before we solve, it has to be equal to 0. 2x squared plus 7x minus 4 equals 0. X equals -7 plus or minus the square root of b squared minus 4 times a times c. This one's not going to come out a perfect square root. All over 2a. So then from there, let's see what's under our square root. The more people helping us out, the quicker. We do need to see the few different things to make sure we're good. Anyone? 81
I
again?
think it's 81.
Well, the freak, we don't want to see any more with whole numbers. Okay, we're going to move on because we get how to do that. This one's better. This one doesn't. I know that. So x equals negative b plus or minus the square root of b squared. Start typing it in. Minus 4 times a times c all over 2 times a. So x is equal to 4 plus and minus the square root of.
About 68.
No, but thanks for trying.
Oh.
Negative.
Oh, negative.
So negative 36. So then from there you go out to the side and say the square root of negative 36 is 6i, isn't it? So 4 plus and minus 6i over 2. Don't all three things divide by 2? So this divides by 2 becomes a 1, a 2, and a 3. So our answers are x is equal to 2 plus and minus 3i, which is our two solutions, right? Because we could split it up if we so desired. Okay. Do you want to see what if under a radical doesn't break down? What would our answer look like? Look, let's see if I had this. 4 plus and minus the square root. I'm making this up on the spot. Square root of 8 all over 2. Can I divide 4 and 2 out?
Yes, but you
Oh,
can't.
wait, no, you can't.
There's it.
Yeah.
No.
Yeah, so no unless we can divide all three things, right? We can't divide across addition and subtraction. But what would our next step be? Simplify square root of 8, which is 2 times 2 times 2. So then we would have 4 plus and minus 2 roots 2 over 2, wouldn't we? And now we could. Okay, awesome. Okay, so this is the last part of the lesson here. Oh, this one, how would we solve this one? Is it even quadratic? No, it's rational. Don't we need a common denominator? They're going to throw a wrench in on the test and give you one like this because it ends up being quadratic, so it tests two things at once. How do we solve rationals? Get a common denominator. So what do we multiply by m over n? M over n. And then what can we do with our denominator?
Cross it out.
Cross it out with solving. So then we'd have 9m squared plus 4 equals 12m. And then you'd say I have to get a set equal to 0. So that's 9m squared minus 12m plus 4 equals 0. And then if it says solve with the quadratic formula, we'd go for it, right? Solve by method of choice. We could do whatever method we like best. I wouldn't complete the square if there's a 9 in front. Would you? No, because then we have to factor it out and do it. I only complete the square by choice if it's going to be really nice and easy. So I have quadratic formula of that, personally. Do you mind if I don't quadratic formula and just move on? Because I feel like no one cares anyways, because they can already do the quadratic formula. Okay, so these are the three. This is where people have a hard time. Seeing the different types of solutions and understanding where they come from and why we have these answers. So you're going to be asked, what type of solution will you have? Not solve, but what type of solution? You don't want to have to go through and solve every time. So look, let's say that this scenario happens. What happens? So if we have the square root of 9, isn't that a perfect square root?
Yeah.
So that would be 3 plus and minus 3 root 3, which if you think about it, 3 plus 3 is 6. 6 divided by 3 is 2. We have one solution, which is 2. 3 minus 3 is 0. 0 divided by 3 is 0. Do you see what we get? Two solutions that are rational. Rational means can be written as a fraction. Okay, and they're not equal. Those would be two unequal rational solutions. So if the square root is a perfect square, so that would be 3 plus and minus 7 over 2. It comes out to be two rational solutions that are not the same. 3 plus 7, 7, 8, 9, 10. 10 divided by 2 is 5. 3 minus 7 is negative 4. Negative 4 divided by 2 is negative 2. Do you guys see how that works? Okay, so then, what if we have a radical that doesn't break down? Then we're going to have two irrational solutions because we can't actually combine them. Those are not fractions, right, everyone? They are fractions, but they're not things that can be written as a fraction. That's a decimal. If you were to type that into your calculator, you could not rewrite that as a fraction. This is irrational. Irrational means radical is still left in the answer that can't be simplified. You guys see what I'm saying? So if under the square root is not a perfect square, then it's going to be two irrational solutions. So that's plus and minus, right? I don't know why I wrote this plus. It's plus and minus. You guys see where the two irrational solutions come from? Right here, you'd say, well, the radical does break down because it would. You'd go off to the side and do 3 times 3 times 3. So this would be this. 3 plus and minus 3 root 3 over 3, which is 1 plus and minus root 3. Isn't that still two irrational solutions? Yes, because they're still a radical. So if there's still a radical left, There's two irrational solutions. Now what if it's a 0 under the square root? Well, then we have this. 3 plus and minus the square root of 0 is 0, all over 4. Is that the same answer or what? 3 plus 0, 3 minus 0, same thing. 3/4. Do you see how we get one solution, but we get it repeated twice? One repeated solution. So if under a square root 0, we get a repeated solution. Now if we have a negative under our square root, we know that's where our imaginary solutions come from, obviously, right? That one's the most obvious to us. Two imaginary solutions. Okay, so here is that rule in general. So where really mattered when it came to what type of solutions? Under the square root. That part of the quadratic formula, you guys, is called the discriminant. It helps you discriminate against what kind of answers you're going to get. So if I say to you, what type of answers are you going to get? You don't want to have to solve them all. It'll take you too long on the test. You want to be able to just calculate the discriminant and think. Well, under my square root, I'd have this. So this is the type of solution I have. So this is the page I would be writing down or taking a picture of. So if under your radical is a perfect root, that's when we get two unequal rational solutions. That means two unequal solutions that can be written as a fraction. When under the radical is not a perfect root, and we cannot simplify the radical to be gone, then it would be two irrational solutions. Cannot be written as a fraction. And if under a radical is 0, we get one solution that's repeated twice. If under the radical is negative, that's where we get our two imaginary complex solutions, because complex numbers are a plus bi. So two imaginary solutions. So you only want to calculate what's under the square root. So let's just look at a few last examples and I'm done. Watch. Let's go through and do these. You'll see that it's actually easy. It says, use the discriminant to determine the type of solutions you will have. So you'd say, okay, I have to get it equal to 0, then I don't want to calculate. I don't want to actually go through and solve it. I only need what's under the square root, which you already know is b squared minus 4ac. It's not even anything extra to memorize. So then you would do b squared, so that's 5 squared minus 4 times a times c. So isn't that 25 minus, it looks like 16 times 2, so 25 minus 32, isn't that a negative number? That's what's under our square root, a negative number. So what type of solutions will I have? Two imaginary solutions. Pretty easy. So then right here, the first thing we would need to do is add 9. So we have 4x squared plus 12x plus 9 equals 0. Then you'd say, what type of solutions? You'd say, well, what's under my square root? B squared minus 4 times a times c. So then that's 144 minus 144, which is 0. So how many solutions do I have? Two of the same solutions. So they'll say actually one of the same solution, but it's being repeated twice. Same thing you just said. Yes. Everybody understand? Yeah or no? Yes. Okay, almost there. So b squared, so we would do negative 4 squared minus 4 times a times c. So that'd be 16 minus 8, which is 8. The square root of 8 is 2 roots 2. Do we still have a radical? Yeah. So that would be 2 irrational solutions. Does everybody get it? What if I have the square root of 49? That's 7. So that would be 2 rational solutions that are not the same. They're not the same solution. Everybody good? That's the end of the lesson if you're good. Yeah? Okay, awesome. Actually, no, it's not. Here's why. Okay, you can't go and cry and say, well, I can't do story problems if you don't quickly see 2 examples. We'll go quick. We won't even go through the whole thing. We'll just show you how to set it up. It says a revenue function of a company selling X number of t-shirts per week is given by this function. R of X is equal to that. How many t-shirts must be sold in order to get $25,000 in a week? Where would I plug in 25,000? Into R of X, right? Not X. That's not the number of t-shirts. It wants $25,000 in the end. So 25,000 is equal to negative 0.005x squared plus 30x. How do we solve quadratics? We get it set equal to 0. So I'm going to subtract that over. And then because this is such huge A numbers, I just said huge A on my video. Okay. So, seriously. So guys, quadratic formula, huge ones. I would never do anything else. Quadratic formula and there's our answer, right? Now think about it. If we have a plus and minus, let's say we have a negative answer. X is equal to negative 10, for example. Well, can you have negative numbers of t-shirts? So we throw that answer out for this story problem. Does that make sense, everyone? But just quadratic formula it, and that'll be your answer. Okay, last example. It really is, truly, I promise. So it says a window designer wishes to design a window so that the diagonal is 20 feet. So I drew a window and I'm drawing a diagonal of 20. What do you think that looks like? A right triangle. Good. So then from there it says, in addition, the length of the window needs to be 4 feet more than the height. So the height is x, so this is x plus 4. And then it says, what are the dimensions of the window? So we need to find what x is, don't we? What's the true statement? This squared plus this squared equals this squared, right? So x squared plus parentheses x plus 4 squared equals 20 squared. So then we have x squared. We wouldn't break forbidden rules. So we actually have x plus 4 times x plus 4 equals 400. So then we actually have x squared plus 8x plus 16 equals 400. So then we would have 2x squared plus 8x. And then we would subtract 400 over, right? Yeah, to get it equal to 0. So wouldn't that be 84? Minus 384 equals 0. And then because they're such big numbers, I would quadratic formula that. Do you agree? We get 2 solutions. Can you guys do the story problems? Pretty easy. Okay, sweet. That's the end. That really is. So go practice some of those.